Space, the final frontier, an endless expanse that beckons with its mysteries. It's a realm of vast distances, swirling nebulae, and enigmatic black holes, each more fascinating than the last. Our universe is a marvel to behold, filled with billions upon billions of galaxies, each home to countless stars, planets, and perhaps even life. But what lies beyond what we can see? What secrets are hidden in the dark corners of the cosmos? What secrets hide at the very edge of the observable universe where light has barely reached us? Imagine standing on the shore, gazing at the seemingly endless expanse of the ocean, feeling the pull of the unknown. Just as the horizon marks the limit of our vision on Earth, there exists a cosmic horizon in space, a boundary we strive to understand. It's the furthest point from which light has had time to reach us since the Big Bang, a marker of the universe's age. Anything beyond this cosmic horizon remains shrouded in mystery, a tantalizing enigma. Yet humans, driven by an insatiable curiosity, yearn to pierce this veil of the unknown, to uncover what lies beyond. We build powerful telescopes, their lenses like giant eyes staring into the depths of space and time seeking answers. These instruments become our time machines, allowing us to observe light that has journeyed for billions of years, revealing galaxies as they were in their infancy, a glimpse into the past. The pursuit of the most distant objects in the universe is more than just a cosmic scavenger hunt, it's a profound journey. It's a quest to understand our own origins, to unravel the story of the universe's birth and evolution, a narrative written in the stars. Each new discovery, every distant galaxy we find, adds another piece to the puzzle of our existence, bringing us closer to the ultimate truth. In 2016, astronomers made a groundbreaking discovery that would change our understanding of the cosmos. Using the Hubble Space Telescope, they identified GNZ11, a galaxy so distant that it became the new record holder for the furthest object ever observed in the universe. This faint smudge of light, barely visible even to our most powerful telescopes, offered a glimpse into a universe just 400 million years after the Big Bang, a time when the first galaxies were beginning to form. But the story doesn't end there. The quest to understand the early universe continues to push the boundaries of our knowledge. In recent years, even more distant galaxy candidates have emerged from the depths of space, challenging our previous records and expectations. One such candidate, Jade's GSZ 13-0, was detected using the James Webb Space Telescope, an instrument that has revolutionized our ability to observe the cosmos. This incredible instrument, launched in 2021, is pushing the boundaries of astronomy, allowing us to probe even deeper into the universe's past and uncover secrets that were previously beyond our reach. The discovery of these ultra-distant galaxies has profound implications for our understanding of the early universe, shedding light on the conditions that prevailed shortly after the Big Bang. They provide clues about a pivotal era when the first stars and galaxies began to form, illuminating the darkness of the cosmos and setting the stage for the universe as we know it. These early galaxies, much smaller and less structured than our own Milky Way, played a crucial role in shaping the universe we see today, influencing the formation of subsequent cosmic structures. These discoveries also raise intriguing questions about the nature of the universe itself, prompting scientists to rethink existing theories. If galaxies could form so quickly after the Big Bang, what does this tell us about the conditions in the early universe? Were the processes of galaxy formation more efficient than we previously thought? Did gravity work differently back then, or were there other unknown factors at play? These are questions that astronomers are eagerly trying to answer as they continue to explore the vast and mysterious expanse of the universe. But how do we measure the distances to these incredibly faint and distant objects that are light years away from us? The answer lies in a fascinating phenomenon called redshift, which is crucial for our understanding of the cosmos. Redshift is the cosmic equivalent of the Doppler effect, which we commonly experience with sound waves here on Earth. Imagine an ambulance speeding past you, its siren blaring loudly as it approaches. As the ambulance approaches, the sound waves are compressed, resulting in a higher pitch that we can hear. As it moves away, the sound waves are stretched, producing a lower pitch. Light waves behave in a very similar manner. When an object in space, such as a galaxy, is moving away from us, the light it emits is stretched, shifting towards the red end of the electromagnetic spectrum. This stretching of light waves is what we refer to as redshift, a key concept in astrophysics. The greater the redshift, the faster the object is moving away from us, and consequently, the farther away it is in the vast universe. By carefully analyzing the light from distant galaxies, astronomers can measure their redshift and calculate their distances with remarkable precision. In the case of GNZ11 and JADE's GSZ13-0, their extreme redshifts indicate that we are seeing them as they were just a few 100 million years after the Big Bang, offering a glimpse into the early universe. Redshift is an essential tool for astronomers studying the universe on its largest scales, helping us understand the cosmos better. It has allowed us to chart the expansion of the universe and trace the distribution of galaxies across space and time, revealing the dynamic nature of the cosmos.